So we just did it with a special case. We did it with a special case of 4 subintervals, and we got an approximation. Suppose I went through and did 5 subintervals and took the midpoints instead. So let's take this same idea and try 5 subintervals and heights using midpoints. So the first thing I have to do is figure out where the subintervals are. How much? 0.4, right? So I take 1 minus -1 over 5, that's my delta x, difference in the left and right hand endpoint divided by the number of pieces I want. So that's 2 over 5, which is 0.4. So my points are going to be 0.4 units, so there's my x1. 0.4 units over will be here, that's x2. 4, that's x3. 4/5 of the unit over is going to put me here, that's x4. And then here's x5. And then for each of those, I want to go through and find the midpoint to find the height. So the midpoint, well, these are each 4/10. This is halfway, this is 2/10. My height of my first rectangle is going to be about there. And so what I have is my x1 bar is -0.8, and so my area of the first rectangle is equal to f of -0.8 times 0.4, my common width. And about how high is that? 0.6. Actually, a little bit lower than that, maybe 0.59. So this is, say, 0.59 times 0.4. And then the next one, my midpoint is going to be here. So this was x1 bar. This is x2 bar. I should have marked this as x0. And so x1 bar comes up to here. That's my height. Bring that over, and bring that over, and bring that down. And so this is x2 bar is 0.8, so A2 is f of -0.4 times my common width, and f of -0.4, maybe about 0.97. So we'll need that area. And then over here, this is x4 bar, this is x5 bar, and we get a height here that I think looks about the same as over there. So this is A5 is f of 0.8 times 0.4. And that looks like about 0.59 times 0.4. And so if we add all those up, well, what's 0.4 times 0.59? 0.236. Okay, so that's about 0.236, and then for that we want to add 0.4 times 0.97, and then 0.4 times 1. And then 0.4 times 0.97, and then 0.4 times 0.59. So what does all that add up to? 1.648. 1.648. Now I know what the actual area is because I created the problem. I know the actual area is exactly 1.6. But here we used 5 rectangles. That gave us a better, more believable result in the right-hand endpoints because we didn't lose that entire last rectangle. And we also used 5 subintervals instead of 4. So take that 5 subintervals, and so what that looked like was we had some height in there. It doesn't really matter where we take it. So we take 5 subintervals. In fact, let's go back and look at, now let's just do this. That's fine. We'll take this endpoint over here. And now, so if I go through and cut each of these 5 intervals in half, and then I go up and say, well, let's take this interval and maybe use the midpoint. And if I come in and take this interval and maybe use its midpoint, and take the next interval and use its midpoint, and take the next one and use its midpoint, then what ought to jump out is that you're not getting as much error. You're not getting as much overage and underage, right? The error that we previously had with the red was all of this stuff, the stuff that wasn't being counted. In fact, it was actually all of that stuff. Well, the idea is that if I increase from 5 to 10, well, by making more rectangles, I wind up getting rid of a lot of the under and overestimating. Well, if 10 rectangles is good, 100 would be better. And if 100 rectangles is good, 1,000 would be better. So if you look in section 5.1 in the textbook, you'll see these kinds of pictures that have more and more rectangles. Now, doing this by hand gets to be a real drag. Yeah, you're given that. Does this take the same thing as throwing darts pretty much? No, this is not the throwing darts thing. This actually gives you a better answer with a lot fewer rectangles. You don't need 100 million darts in order to get a good, or 100 million rectangles to get a pretty good approximation. I briefly want to introduce you to an idea, though, that I think some of you will like and some of you will hate. I find more and more students like it. So what we have is less error with more rectangles. Because basically all of this stuff that you were either counting or not counting that was extra, you can take care of it by making more rectangles closer together.